Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first three parts of sequences and series topic where I have covered arithmetic, geometric and harmonic progressions, what are arithmetic mean, geometric mean and harmonic means, and so on. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see what is an AGP series and some more series and how we can find their sums. So let us start with today's video. First, let us see what is an AGP series. An AGP series is a mixed series which is a combination of an AP and GP series. For example, if we consider this series, say 1 plus 2x plus 3x square plus 4x cube plus 5x4 and so on, and say this series is extending till infinity. In this series, if you observe carefully, the first part of each terms, that is 1, 2, 3, 4, 5 and so on, is an AP series where 1 is the first term and 2 minus 1 or 3 minus 2 or 4 minus 3, which is equal to 1, is the common difference. And the second part of each term of the series are x raised to power 1, x square, x cube, x4 and so on. And this series is a GP series where the first term is x and the common ratio is x square by x or x cube by x square or x raised to power 4 upon x raised to power 3, which is equal to x. So that's why this series, which is a combination of an AP and GP series, can be termed as an AGP series. Now, for such kind of series, we can also find its sum. Let us assume that the sum for this series is S. Now, if we multiply x to both sides, in that case, this would be S into x equal to x plus 2x square plus 3x cube plus 4x raised to power 4 and so on till infinity. Now, if we subtract these two equations, in that case, we'd be getting s minus sx equal to 1 plus 2x minus x would be giving us x plus 3x square minus 2x square would be giving us x square plus 4x cube minus 3x cube would be giving us x cube and so on, and this would be again extending till infinity. From this s minus sx, we can take s common. In that case, we'd be left with 1 minus x. And the right hand side is now an infinite GP series where 1 is the first term and x is the common ratio. And we know for an infinite GP series, if the common ratio is less than 1, in that case, the sum of the infinite GP series is given by a upon 1 minus r, where a is the first term and r is the common ratio. So if we apply this formula, in that case, this infinite GP series can be written as 1 upon 1 minus x. So this sum S can be written as 1 upon 1 minus x whole square. So if an AGP series is in this form, then the sum of this series can be written as 1 upon 1 minus x whole square. For example, if an AGP series is given as 1 plus 2 by 3 plus 3 by 3 square plus 4 by 3 cube and so on till infinity, in that case, the sum for this AGP series can be written directly as 1 upon 1 minus x whole square. And here the value of x is 1 by 3. So this would be 1 minus 1 by 3 whole square. And if we simplify this, this would be 9 by 4. So if an AGP series is given in this way, we can directly use this formula and we can find its sum. In a similar way, say if a series has been given in this way, say 1 plus 3x plus 6x square plus 10x cube and so on till infinity. And we need to find the sum for this series. Here also, if you look carefully, the second part of each term forms a GP series as the terms are x, x square, x cube, x raised to power 4 and so on. And this is also extending till infinity. But the first part of each term does not form an AP series as the terms are 1, 3, 6, 10 and so on. And here the difference between the first and second term is 2. The difference between the second and third term is 3. The difference between the third and fourth term is 4 and so on. But the difference of these differences is constant. For example, 3 minus 2 is 1, 4 minus 3 is also 1 and so on. So for such kind of series where the second difference or the third difference or the fourth difference is same, we can also apply the similar approach that we have applied here. So if we assume the sum for this series to be S, and if we multiply x to both sides, in that case, this would be Sx equal to x plus 3x square plus 6x cube plus 10x raised to power 4 and so on till infinity. Now again, if we take the difference of these two equations, in that case, this would be S minus Sx equal to 1 plus 3x minus x would be giving us 2x plus 6x square minus 3x square would be giving us 3x square plus 10x cube minus 6x cube would be giving us 4x cube and so on. Now we already know the sum for this series, which is given by 1 upon 1 minus x whole square. And from this s minus sx, we can take s common, and this would be s into 1 minus x. So the sum for this series s can be written as 1 upon 1 minus x whole cube. So if we have a series which is in this form, we can directly apply this formula. Also, to find the sum for such kind of AGP series, we can apply the similar approach. That is, we can assume the sum to be S, and then we can multiply the common ratio to this sum, and then we can take the difference, and then finally we can simplify it to find the sum. Now, let us see this question where we can apply the same approach that we have just learned. So we have been given a series as 1 plus 4 by 7 plus 9 by 7 square plus 16 by 7 cube and so on till infinity. And we need to find the sum for this infinite series. Here also, if you observe carefully, this series is a combination of two series, where the first series can be thought as 1, 4, 9, 16, 25, and so on. And the second series can be thought as 1 by 7, 1 by 7 square, 1 by 7 cube, and so on. This second series is a GP series where the common ratio is 1 by 7. But the first series is not in AP directly, as the difference between the second and the first term is 3. The difference between the second and the third term is 5. The difference between the third and the fourth term is 7 and so on. But the difference of these differences is constant. For example, 5 minus 3 would be giving us 2. 7 minus 5 would be giving us 2 and so on. So to find the sum for this series, we can apply the same approach that we have learned a few minutes back. So let us assume the sum of this infinite series is given by S. So this S would be equal to 1 plus 4 by 7 plus 16 by 7 cube and so on. Here, the common ratio is 1 by 7. So let us multiply 1 by 7 to both sides. So in that case, this would be S by 7 and the right hand side would be 1 by 7 plus 4 by 7 square plus 9 by 7 cube plus 16 by 7 raised to power 4 and so on. Now, if we subtract these two equations, in that case, this would be s minus s by 7 and this would be equal to 1 plus 3 by 7 plus 9 by 7 square minus 4 by 7 square would be giving us 5 by 7 square plus 16 by 7 cube minus 9 by 7 cube would be giving us 7 by 7 cube and so on. Now, to find the sum for this series, we'll be applying the same approach as this series is an AGP series. So if we consider the sum for this series to be S dash, in that case, this would be S dash equal to 1 plus 3 by 7 plus 5 by 7 square plus 7 by 7 cube and so on. And here, the common ratio is 1 by 7 again. So let us multiply 1 by 7 to both sides. So this would be S dash by 7 and this would be equal to 1 by 7 plus 3 by 7 square plus 5 by 7 cube and so on. Again, if we take the difference, in that case, this would be S dash minus S dash by 7 and this would be equal to 1 plus 2 by 7 plus 5 by 7 square minus 3 by 7 square would be giving us 2 by 7 square. 7 by 7 cube minus 5 by 7 cube would be giving us 2 by 7 cube and so on. So this would be 6 by 7 S dash equal to 1 plus, we can take 2 by 7 common from this term. So this would be 2 by 7 times of 1 plus 1 by 7 plus 1 by 7 square plus 1 by 7 cube and so on. Now, this part is an infinite GP series where the first term is 1 and the common ratio is 1 by 7. So we can directly apply the sum of an infinite GP series formula. So in that case, this would be 1 plus 2 by 7 times of a upon 1 minus r. So this would be 1 upon 1 minus 1 by 7. Now, if we simplify this, this would be 6 by 7 S dash would be equal to 4 by 3, which would be giving us the value of S dash to be 14 by 9. So finally, from here, we can write it to be as 6s by 7 equal to 14 by 9, which would be giving us the value of s to be 49 by 27. So that means the sum for this infinite series is 49 by 27. Well, you may have found this question to be a little bit lengthy, but if you practice a couple of such questions, you'd be very much comfortable in solving such kind of questions. So that's why I would suggest you all to practice some more questions of such types. Now, let us see some more series and how we can find the sum for those series. So here we have been given a series 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 and so on. And we need to find the sum of this series till 50th terms. Well, to find the sum for such kind of series, the best approach is to find the nth term and then to express the nth term as a difference of two fractions. Here, if you observe carefully, the denominator of the first term 2 can be written as 1 times of 2. And the denominator of the second term can be written as 2 times of 3. In a similar way, the denominator of the third term can be written as 3 into 4. The denominator of the fourth term can be written as 4 into 5 and so on. So if we write the generic term, that is the nth term for this series, in that case, this can be written as 1 upon n into n plus 1. As for the first term, the denominator is 1 into 2. For the second term, the denominator is 2 into 3 and so on. So for the nth term, the denominator would be n into n plus 1. This nth term can be expressed as a difference of two fractions, as 1 upon n into n plus 1 can be written as 1 by n minus 1 upon n plus 1. Now, if the nth term can be written as 1 by n minus 1 upon n plus 1, in that case, we can write the first term t1 as 1 by 1 minus 1 by 1 plus 1, that is 2. In a similar way, the second term t2 can be written as 1 by 2 minus 1 by 3. The third term t3 can be written as 1 by 3 minus 1 by 4, and so on. And since we want to find the sum of this series till 50th terms, so the 50th term can be written as 1 upon 50 minus 1 upon 51. In a similar way, the previous term, that is the 49th term, can be written as 1 upon 49 minus 1 upon 50. Now, if we add all these terms till 50th term, we'd be getting the sum of this series till 50th terms. So, T1 plus T2 plus T3 till T50 would be giving us the sum of this series till 50th term, which would be 1 minus 1 by 2 plus and so on till 1 by 49 minus 1 by 50 plus 1 by 50 minus 1 by 51. Now, if you observe carefully, the second part of the first term is getting cancelled with the first part of the second term. In a similar way, the second part of the second term is getting cancelled with the first part of the third term, and so on. So, the first part of the last term would be getting cancelled by the second part of the second last term, and so on. So, after all these cancellations, we'd be left with 1 minus 1 by 51. And this would be giving us the sum of the 50 terms of this series. So, this would be 51 minus 1, which would be 50 upon 51. So, the sum of the first 50 term of this series is 50 upon 51. So, in this way, by finding the nth term and then expressing the nth term as a difference of two fractions, we can find the sum for such kind of series. Now, let us see one more question where we are finding the sum of the series by finding the nth term. We have been given the series as 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4, and so on till 1 plus 2 plus 3 plus 4 till 50. And we need to find the sum for this series. Well, some of you might be thinking to use the sum of the first n natural number formula, which is n into n plus 1 by 2. But we need to use this formula to each and every term, which would be very much time consuming. So instead of directly using this formula, let us try to find the nth term for this series, and let us see how we can reduce our time by simply taking the help of the nth term. So here the first term is 1, the second term is 1 plus 2, the third term is 1 plus 2 plus 3, and so on. So the nth term Tn can be written as 1 plus 2 plus 3 plus 4 till n. As for the second term, the last number is 2. For the third term, the last number is 3. For the fourth term, the last number is 4. So for the nth term, the last number would be n. Now we can directly use the sum of first n natural number formula, which is n into n plus 1 by 2. And this can further be written as 1 by 2 times of n square plus n. So now the first term T1 can be written as 1 by 2 times of 1 square plus 1. The second term T2 can be written as 1 by 2 times of 2 square plus 2. The third term can be written as 1 by 2 times of 3 square plus 3, and so on till the 50th term, which can be written as 1 by 2 times of 50 square plus 50. Now, if we add all these terms T1 plus T2 plus T3 till T50, we'd be getting the sum of this series till 50th term, which would be S50. So this would be 1 by 2, 1 square plus 1, and so on till 1 by 2 times of 50 square plus 50. From all these terms, we can take 1 by 2 common, and we can rearrange these numbers as 1 square plus 2 square plus 3 square till 50 square plus 1 plus 2 plus 3 plus 4 and so on till 50. In the last video, we have seen the sum of the square of first n natural number, which is given by n into n plus 1 into 2n plus 1 upon 6. So let us try to use that formula here. So in that case, this would be 1 by 2 times of 50 into 50 plus 1 times of 2 into 50 plus 1 upon 6. And this would be the sum of the first 50 natural numbers, which is given by n into n plus 1 by 2. So this would be 50 into 50 plus 1 upon 2. Now, if we simplify this, this would be giving us 22100. So that means the sum of the first 50 terms for this series is 22100. So in this way, by finding the nth term, we can find the sum of the series. So that's it for today's video, in which we have seen what is an AGP series and some more series and how we can find their sum. And with this, we come to an end of sequences and series topic. I would suggest you all to practice some more questions on this topic, because the more you practice, the more you learn. I hope you have learned something in these videos, but if you have any confusion, you can watch the videos again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.